Okay, so this is the second of a two-part video overview of CAD's A3D Max for the analysis of general structures and links to design and detailing. Introduction I gave you in the video at the beginning covers most of this. What we're focusing on in this session will be links to CAD design and detailing software. Key features as before, but as I say, we're now looking at display of forces, moments and deflections, automatic creation of combinations for Eurocodes, and then links to steelwork design, reinforced concrete design, and then a multiple set of ways of exporting the details as CAD's RC drawings and schedules, layout drawings in 2D, IFC, and even 3D PDFs. Just an overall flowchart here, so you can see the sort of functionality I'm playing with in the presentation here and how the programs all fit together. You've got CAD's A3D Max here as what I would call the core. That's your analysis. Then for steelwork, we go to the right, and for concrete to the left. These programs are all individually licensed, so if we're talking to clients who typically only do steelwork, not to worry, you don't buy programs you don't need, and indeed you can differentiate between connection and member design. So 3D Max will link automatically to connections and member design in steelwork and through to a steelwork detailing that you can see in AutoCAD later on. And then in concrete, we've got pile caps, pad bases, columns, and RC beams that link to 3D Max. And all of these can be designed and then subsequently passed on to CAD's RC for full detailing, annotation, and automatic scheduling. Let me show you how we can display the results of the analysis on a small little frame like this in a few seconds. You may notice when you start the program or indeed begin a new job, you get a display screen like this, and it's actually asking you for a code group. Now, CAD's A3D Max isn't a design program, but the reason we differentiate like this is for the Eurocode, we've put some added tools into the process of combination generation. You can see in the model here, the toolbar here has actually got an extra button here for combination generation, and if you study what's on the screen here, these are all the clauses in the code for generating all the different types of ULS and SLS cases, all the partial factors and so on. So indeed the user can then choose all or some of these. You can turn off individual load cases or you can turn off groups, and you produce then an automatic set of combinations that suits your project like I've got here. And you'll notice they're broken down into serviceability and ULS combinations. So one knows whether to do deflections and the other one knows whether to do design. You can add your own. I've put my own in here for self-weight, dead and live, and that's very easy. You just create a combination, tell it what it is. You can even in our program choose linear or P-delta or plastic analysis for general frames. So that's something else that you can provide there, and you can delete or add as many combinations as you like. So looking at the results, we go to the Analysis and Design tab here, run the calculation, and the first thing you'll get is a box like so. So this is showing us the numerical values. We've got the joint displacements, the different combinations. You can tab through these and you can see the numbers changing. Indeed, you can go to a ULS or an SLS case. You can go across here into reactions. There's even a summation box just to make sure what you put on the model is what you expect to get out of it. And then we go across here to effects and deflections. Now, these are for each member. So you can toggle to the member in question here. It highlights it in the model. And then it's showing you for a varying degree of detail. You can actually change how many points you want to see, what the variation is of axial force and shear along the member. And the same thing with deflections. You can see the normal and axial deflections for a given member for a given set of intervals. And lastly, you've got here limits. It's something you can set up in the program for each or one or two members where you're worried about deflection in the analysis stage. So this is actually letting me put in the span deflection ratio for the normal deflection and a natural value of deflection for lateral. When I've run this now, it's actually telling me what the limit is, what I've actually achieved, and therefore it passes. So just going back to displacements, how do we see a bit more on the frame? These are all very well, these numbers, but it's nice to see the graphics. So we can choose to have a look at the bending moments. I briefly showed you something like this before. You can see I'm choosing member 5. If you don't want to choose that particular member, you can label everything up. Indeed, the program even gives you a chance to see what the maximum values are for the whole frame. Down here again, we've got the ultimate limit state that we're looking at. So I've got the same values above as below. So if we go to that member here now and look at the member 5, you can see I've chosen member 5 here. Got the bending moments. I just want to get a bending moment label for that particular one. There we go. And the values you see on here are 19.3, 8.9, and those are reflected here. Look in the table. So if we check out the axial loads and shear, we just change this to an axial load diagram. We're looking at 94 and 31, and you can see that in the table here. And similarly, the shear force diagram, about 31 each end, and again you can see that here. Deflections, change to a serviceability case, like so. Number 5, want to see the deflections across it, and you can see it's 1.74 maximum there. It's confirmed in the maximums box, and we can change the diagram to suit and turn on the member and normal deflections, and we've got the same thing. Again, I would normally look at these things in a stick mode probably. There we go. Okay, so we can also display the results on the screen. If you just look at the front view, you can choose what you want to see in any particular view and then save it. So I've actually created a set of preset views here. You can see the little box with the types of display I want to see. They're the classic ones you always get. Deflections, loads, bending moments, shear force diagrams, and axial loads, and so on. I've saved those views. There's two benefits then. Those are the views that you can then produce in your document. So you can actually see the views you're going to get before you send them to your output. And also they're there for you to refer to very quickly. And they will change as the model changes and the loadings change within the course of your work. So they are dynamic with what you're doing. So to get a little output, you can see the benefit of those tools I just showed you. We go to print preview. Just click on print preview here. And we have a box where you can choose as much or as little as you want. I've chosen a few topics here to go with what we're doing. You can see the combination of things here. But these are the diagrams. I've got the axial loads, I've got the deflections and so on here, plus a current view, which is why I changed this to rendered. So if I go preview now, it's compiling the document for me. There's the current view. We could change to a couple of consecutive views like so, and then just toggle through the output. There's the members on the left there, joints, member loads, combination values, support reactions, and then you've got the diagrams here then for the axial loads, deflections, bending moments, and so on. There we go. That's basically how to produce the analytical results from CAD's A3D Max. So moving on to actual design, I've got this very simple structure on the screen here, concrete and steel. You can do a mixture of concrete, steel and timber if you wish. These are steel members in the roof members here in the trusses, and then we've got some concrete beams and columns supporting it. If I turn on just something that you might need to see, there's a tooltip there, look, so if you actually want to see what these members are, you just put your mouse over the top and it tells you. So these are 500 by 350 beams, and then these are 300 square columns, and you can see the bracing member 152s. So that's an option in the view screen called tooltips. So you may see when you start the project this option come up. Now this is where we've actually tried to help with Eurocode and all the combinations that come in. British Standard, you put all the factors in yourself and the combinations. Eurocode, you can actually use a generator within the program, and this covers British Annex and Irish Annex and general EN, which you can then tailor to suit your own particular region. All these values can be edited if you put the user defined on. So you'll see now that I've turned that on, a feature that's not in the British option in combinations. It's here, it's the combination generator, and it simply takes you through the clauses in the Eurocode so that it can create the right combinations for your project. You can see the different types of stability and structural characteristic, the serviceability combinations here that you can choose from, whether or not you've got foundations and so on. And that will generate all the different factors for all the different combinations, quite a few of them there. And it leaves you then to choose if you want them all, or if you don't want some of them. And indeed, you can turn off a group, or you can turn off individual ones. Once you've then got that into the program, the user can change these to p-delta or plastic analysis combinations, or indeed you can add your own combinations and put supplement the ones that are here, delete ones it's done if you're not sure about them, or even change the factors yourself. So it gives you a very good starting point and gets most of the work done. I put some loads on this frame just to show you what we've got. We've got some line loads basically on the roof. I've put some area loads here horizontally for the wind load, about 1.5, some floor loads in of 3, and that's what we've basically got for our analysis. So that's just to give you another bit of background. They're two-way spanning, they could be one-way spanning. If you're not sure how to do that, you just click on the panel and you go into the load distribution scheme and change it. So you can make it span whichever way you want. So that's our job. The analysis results that we've already shown you a couple of times, you can see here. Those are the numerical, these are the graphical, bending moments, same sort of thing as you've seen before, shear force diagrams, axial loads, a bit of clarity with the rendering off, and deflections, you can see there, and I can also see, put the labels on, turn the members to the labels on, and just show you the maximum value. It's got about 3 mil there. There we go. So that's just to confirm what you've seen before. Now, for design, there are 2 ways of working really to suit projects like this or smaller projects of a few members where doing anything too clever is a waste of time and doesn't really warrant it. So the first very simple method, very, very traditional, is just pick a member and design it. So the program offers you all these different types of element that it can design. You've got concrete beams, columns, pad bases, pile caps, general steelwork members, and moment connections. So you choose an element, like here, the footing. Now that could be, as you can see here, it's lit up the pad base and the pipe. It could be either of these. So you can choose the pad base designer, place a sort of portal type connection if you like. And then you can see here it's come up with a design that's using some reinforcement and bar arrangement types that you can put in here, as you can see. I'm not going into these programs too much on their own just at the moment. We've got other videos for those. But that gives you the result. You can even see the bearing pressures, which is quite nice. Yeah. So that's how to do an individual, say, pad base or pile cap, and even continuous beams. We can choose a series of continuous beams and export those too. You could choose them individually, or you could, as I've done, choose for them to be continuous. You can see the analysis from the design here. That's the bending moment, that's the shear. Now the clever thing is you can see this is enveloping, and that's because when the program links from the analysis to the design program, it does the pattern loading for you. So that's not required in the analysis. You just put uniform loads into the analysis, which saves a lot of time. And the end result is a detail. And again, there's more on this in a subsequent video. You can see here the details it's giving me. There we go. So that's a very quick method. If you're only doing a few members, it's ideal. Simple little ground beams, that kind of thing. But if it's a frame like this, there's a lot more to do. You'd have to go around every single member and optimize them manually, see which sizes are the best. But we're going to do that for you automatically. And we do that using a method called group member design. The principle behind group member design is to save you having to design every single member that you will eventually be deciding of one type. So for instance, the rafters in the trusses here, the bracing members in here too, maybe the beams. You'll probably want them all to be in a certain group, the same size, but they've all got different forces in them from the analysis you've done. So the program lets you pick which members you want to be of a similar type and then runs the analysis and does that for you. So the first principle of that is to select the members, and you can see I've done that here. So you go to design results and it shows you the groups that you've defined. You can see I've done the steel ones here, that's the main members in the truss, and those are the bracing members, and I've done another group of a couple of beams just to show you how it works on steel and concrete. And you can also see in here we can use this for things like bases and for steel connections, pile caps and so on. So it can be a whole range of different members that you've got in a structure, and it will run them all through and optimize the type of sections for you. If you want to know how to put these together, just a quick show of how to do one. This is a column group. You can see this is lit up. As soon as I've chosen columns, it knows what type of group you are, and then you just put in the group name. You may have more than one group of columns, so you choose 1 or 2 or 3 or whatever, and then that creates a column group, and you're basically where I was when I just opened this up. You've got the members within that group. There we go. So we're going to focus on the 2 other groups that I've got in here, the steelwork and the concrete. I'm going to choose all of these at the same time, both these types of members. We don't have to run them separately. And we're going to do a check on the section sizes here that we put in for the analysis. At that stage, we were basically looking at serviceability and so on. This is now doing code checks for capacity and buckling, torsional buckling and so on. And you can see the checks it's already done. We've got a failure here for the main members, and it looks like torsional buckling is our, or lateral buckling is our problem. And if we want to know where that is, you can see on here, look, so you can see the failures up here, and you can also expand the group, of course, and then see the individual members. If you just turn those checks off, in terms of colors, you can see the main members that are causing the problem here. Look, there we go. So what we need to do is basically run the calc and see if we can upsize this member. I mean, one other way of working with this, you can see I've got these this restraint type of purlin in here. That I did already. So I've set up a range of restraints on the top flange of this member at 1250 centers. Now you could change the pitch here now, reduce it to get it to work. You could put more restraints in at certain positions, and you can indeed create several different types and put them in different areas of the structure. But failing that, if it's just sizing the member that's necessary, all we need to do is run the calc again. But instead of this time doing a check, what we're doing is a design. And you can see we've got 72 members here. It's doing 72 members in flash of an eye, really, there. And we're now, there we go, we see the 254 needs to be a 356. And we've got these results here. We're 90% buckling now. And the 178 that I put in was underutilized because it's gone down to, well, it can't go any further down. It's a 127. So all these are now working. You can see the list where we've got blues and greens. That's all good news. And the bracing as well, giving us the critical load combinations as well, you can see. And that's the steelwork done. And then we can move on to the concrete. We don't do a check with this. It's more of a, it's really a design. You don't put anything in. You just basically use the design default parameters that we've got set up and just run it. So we can run these 2. Let's do the one in the Z direction first. That's this one here. So that's running through, and it's giving us then a list. We'll do the other one as well. Just giving you some idea of the speed. This is all live, so you can see how quickly this is being done. There we go. And what you're seeing in the table now for beam Z, look, is confirmation of the depth and width that it's found for our beam, and then you've got the grade of concrete it's using, and you've got these little groups of bars and where they are in the cross section. You've got that also for the beam running the other way. Now, if you want to see this in more detail, you go to this button here, and it opens up the beam in CAD's RC Beam Designer, which we've got more details of this in another video, and you can see a cross section and the elevation. Indeed, you can move this cursor and have a look at the detail it's come up with. The green here is saying it's all okay. If it goes blue, there's some problems. And indeed, you can play around with the reinforcement that it's given you and so on as well. So very comprehensive program, but that's the beam design. So we've now managed to design all the concrete, and we've done the steel members, and we've optimized the beams that way. Just want to show you some of the results of our labours, and in terms of the concrete beam here, for instance, we do have a link from CAD's A3 Max and RC Beam Design into our detailing software. So I'm just going to show you this beam going through to design and detailing. This one here that we've done. So you open up the details, that puts the beam inside CAD's RC Beam Designer, as you can see here. And you can see all the section details and everything else. And then we simply save this file to the directory we want to use, this one here, save it. And then we can go into AutoCAD And all you have to do in here with CADS RC loaded is push on the link button. So you have to have CADS RC, and you click on the link for RC Beam Designer, choose that same file. So this would be a detailer picking up a file from a design engineer. We've also put in here many of the things that many years ago with DXF and so on were frustrating. You can now choose your own pick points. You can set up, for instance, where the labels are for the ranges, in the beam, above the beam, and so on. You can choose the offsets for the label positions and the sections and everything. So you can configure the whole detail as you would like it. And then it's a question of just pushing a button and giving it I'm just giving it a member name so that you can actually multiply that up. But this is live. This is just showing you the beam we designed just now in 3D Max come through to CADS RC. So it's doing all the labeling, putting all the bars in. So once it's finished doing the elevation, it's going to ask me why I want the section points, because that's the choice I made. Otherwise, it puts 3 in for every beam, and sometimes it's too short and frustrating. So I'm letting the program ask me. I've set up how far I want the sections offset from the beam, so I can choose wherever I like with the mouse, but it's only picking up the horizontal distance, as you can see here. And I'm basically choosing where I want these sections to go. There we go. You can see all the sections being labelled up and so on below. That's it. We can say no, we don't want any more, and just put that down on our drawing sheet. It then says, do you want any more? So you could go back, get some of the other beams and bring those in. And this little label here, by the way, you may be wondering what that is. That's really some insight as to how popular this is. That's actually saying if this isn't removed, it's not been checked. These are all the bar marks, and you've got obviously U-bars and so on in there, which in the Beam Designer you can configure. It's got some dimensions for all the anchorage lengths and so on, and that's it, finished. And of course, the main reason for doing the detailing is also to achieve a takeoff. And in CADS RC here, this is the schedule. There we go. So you've got all the schedule, and indeed you can have a look at report like so, and you've got a proper schedule sheet. And we can do this for beams, columns, pile caps, pad bases, all from 3D Max through to detailing. There we go. There's a up-to-date sheet with all the CADS logos on. You can change those and customize those, and indeed you can get a weight summary as well. So weights, schedule, takeoff of bars, and everything's done. Another method of producing drawings from the CADS A3D Max model we've got on the screen would be using DXF, so that we can create some 2D views of the building and pass that on to the third party. So the way that's done, select whichever view they want to create, go up to the menu option here for export, and down to File, Create Layout Group. We can then choose the view of the building we want and start choosing the style of the grids and so on, whether we want them top or bottom, left or right, 1, 2, 3, A, B, C, and so on. You can then tell the program where to put the DXF file and what scale you want it to be. Create the Finish button, and we get a series of drawings. Now, I've done a few already, so if I just show you the ones I've done, you can see once you've done all the DXF files here, they're put together in this group editor. So these are the different views, the same building. I can still edit these if I want to. The properties will come up and I can edit the scale and so on. And we're ready then to produce some drawings. Go into AutoCAD, and we can see here, that's the elevation you just saw me produce in the group, and then the section here, and you can see the labels on the drawing, the floor levels, the dimensions, steel and concrete labels, basically. Now this is automatically created, but you can edit these, you can add more text, you can change the style of the labeling. It's all AutoCAD, so you can do what you wish with that, but it's a very good start, and it's for free. Another option you saw in 3D Max to send out information was here, 3D PDF. So if you want to send an entire model to somebody, a good scenario would be that you've got somebody you want to talk to on the phone about a model that you're doing. It's too big to email, or you'd rather do it very quickly, or it's just a moment thing. You can send a 3D PDF as a 2D drawing to somebody, but that 2D drawing will actually include a 3D image of your building. There we go. So again, this is automatic. It's click button stuff. We can zoom in as the user. It could be you or the person you've sent it to, and you can rotate and talk about it as you go. There are some nice tools in here that might help the meeting go along more swiftly. You can annotate these buildings. You can see there you can add different dimensions to it and save these views so that you can send it to somebody with different views you've already done. Or you can indeed go into full multimedia view, which is quite nice, a big full screen mode. You can see that down here. There we go. So just pan it up so you can see it properly, and so on. So a very good way of communicating ideas to other people that way. And the other option that we've got, as you can see here, is IFC. Now in 3D Max, you can see in the export option there, IFC. So this entire model was saved to a file. We go into our Revit system. This is Revit 2023. And that's what you get instantly by bringing the file in. That's done through the file menu. We just say open IFC file. Once in here, then we've got the views. We can create elevations in the north and the east, and level 1, that's a plan view with dimensions I've added, and so on. So just to summarize, this is the flowchart again of the connectivity between CAD's A3D Max, the 2D, 3D frame analysis, through to steelwork connection and member design and detailing, and then optionally here to concrete members such as pad bases, pile caps, beams and columns, and subsequently into CAD's RC for detailing, and even an IFC export. Sort of images of the work we did in this session. I showed you the typical way to produce annotation of internal forces, including deflections, moments, shears, the labeling of such. And we looked at the design. So this is showing the green and the red pass and fail annotation for design checks of the steel frame. I then showed you DXF for doing layout drawings, automatically created from the program. And then CAD's RC Beam Designer for the annotation of the continuous beams. And also it could be pile caps, pad bases, columns, and scheduling. Thank you very much for listening. I hope that hasn't been too long. It's difficult to put these sort of things into a short meeting, but at least you can get a very good overview of this. Any questions it raises, please contact us. You can ring on the number below, email us at sales@cads.co.uk, or indeed visit our website, see some more information there. I look forward to hearing from you. Thank you again very much, and have a good rest of the day. Appreciate your time. Thank you.